This is about the basics of wells. There are three main types of wells: drilled wells, bored or dug wells, sandpoint wells. Some common components of wells include the well casing or the hole stabilizer. Basically, it's a tube-shaped structure placed to maintain the well opening and to prevent soil from collapsing into the well. And again, its main purpose is to keep dirt and excess water out of the well. It also prevents contaminants from mixing into the drinking water. Next, we have the well cap, which is at the top of the well casing and should be at least 18 inches above ground. It prevents insects and animals from getting into the well. They are vented to control pressure when pumping the well. And the well cap is made of aluminum or plastic and should be fixed on the well cap. Next, we have the well screen or the inlet. It's attached to the bottom of the casing and it prevents small sediment from entering the well. It allows groundwater to enter from the bottom, and the manufacturer's screen again prevents that sediment getting into the well casing. Next, we have pumping. So pumping motors and electrical lines allow groundwater to be distributed to your home. There are two main pumps, the first one being a jet pump, which draws groundwater from the surface, and it can only operate in a maximum depth of 7 feet. Again, a jet pump is in your pump house, pumping from the surface. Next, we have the more commonly used submersible pump. It's used in deep wells, and this pump is submersed into the well casing and is connected to a power source from the surface. Again, this pump can draw water from wells deeper. And yeah, it's important to have proper screens in your wells as sediment can damage the pumps. So let's talk about the types of wells. The first one is the drilled well. So it's drilled with a rotary or a cable tool and has a small diameter casings. Some of its pros of drilled wells are that it can reach deep into aquifers and it can drill into bedrock. It's less likely to be contaminated and easier to seal and maintains a constant temperature. Some cons of drilled wells are that it's vulnerable to deep water, deep aquifer contaminants. For example, all the minerals, and will lead to hard water. Next, we have large diameter wells, so dug or bored wells. So dug wells are dug by a backhoe or by hand and tend to be shallow. They do have a large diameter casing, so 60 to 120 centimeters, as opposed to drilled wells, which have smaller diameter casings. Some pros are that it's easy to construct and large casings provide more storage. And it's used, can be used in poor yielding aquifers. So any aquifers that don't provide enough water, you can use dug wells. Next, we have bored wells. These are constructed with a boring machine, can be shallow or deep, and has a large diameter casing. It's more controlled than a dug well, but a bit more expensive. The large casing, again, provides more storage for poor yielding aquifers. And the cons of both of these large diameter wells is that if there are shallow aquifers can lead to water shortages, and it's easy to seal, but it requires a lot of material to seal the well casing, and it is very vulnerable to nearby surface contamination, and the water temperature can change seasonally. The last type of well are well points or sand points. These are driven or jetted water with a shallow diameter casing. It's 2 to 5 centimeter casing, very narrow. It's small and inexpensive to install, which is a pro, but its cons are that it's limited to permeable materials, so like sands, and can only be used in shallow water tables, and it produces a limited yield that is vulnerable to surface contaminations. So rights and responsibilities for wells. Owners must maintain each well to keep out surface water and other foreign materials, and unused wells should be plugged and sealed. Plugging and sealing unused wells. So again, wells are a direct access to groundwater and should be sealed and plugged when it's decommissioned to prevent the contamination of that deep water. Again, a well that won't be used again should be plugged to protect the aquifer from surface contamination, prevent vertical movement of water between aquifers and ground surface water, and to eliminate safety hazards to humans, wild stocks, and wildlife. Wells in fractured bedrock must be plugged by a licensed contractor, and it's important never to add water or waste into unused wells. And then lastly, a new well must be properly plugged and sealed if it is dry or the water is not proper for drinking. So again, types of pumps, we have shallow well pumps or jet pumps, which creates a vacuum outside of the well. The lift is limited to 7 meters, and deep well pumps, which are the submersed pumps within the well itself, produces more pressure. So the size of the pump depends on the capacity of well, the demand of water, the height or lift required to get the water out of the pump or well. If a pressure tank is too small, the pump must be used frequently to maintain water pressure. Excessive use can lead to the damage of the pump if, again, it's too small, it's overworked. If well yield is expected to be less or water demand is expected to be too high, extra water storage should be provided through reservoirs or water towers. Pump installation, they should be installed according to Ontario regulations, and all connections between pump and well must be watertight to avoid well contamination. The pump intake will pull in sand, so it's very important to have a screen to prevent the damage of the pump. Low producing wells should have a system shut off if the water levels are too low, and basically this will protect the pump from just endlessly working to try to maintain pressure when there's no water in that well. All submersible pumps should be dry and frost proofed. And we need to ensure that the oil from the pump doesn't contaminate the well. All the plumbing and electrical components must meet their respective codes. And then the pump capacity shouldn't exceed the well yield or available storage. Lastly, it's important never to enter a well pit. So old wells, the wellhead is usually dug deeper into the surface, and the reason why is that it tends to have low oxygen and can lead to death from suffocation. As well, gases such as methane within the well pit can cause explosions. So best practices for wells. So the location must be a proper distance away from contamination sources. Wells should be constructed higher from potential contaminants due to groundwater flow. So for example, you want the wellhead to be on a hill, and you want the contamination such as agricultural activities to be at the bottom of the hill. Groundwater can push things like pesticides into the wellhead, contaminating the groundwater. We need to prevent surface water from contaminating the well by building a mound around the well cap, and then The watertight casing should be at least 6 feet deep. So well construction, the location is very important when making wells. Must meet regulation and needs to be a certain distance away from contamination sources. So for drilled wells, these are the deep wells, should be 15 meters away from contamination sources. Dug wells, which are vulnerable to contamination and are shallow wells, must be 30 meters away from a contamination source. And then shallow wells, so these are wells that have soils with quick percolation, should be more than 30 meters away from potential contamination. Distances alone won't ensure water safety. Septic beds and groundwater flow. So effluent from drain fields or septic systems can flow in the direction of a well due to groundwater flow. Groundwater flow stays the same throughout the year and is harder to predict groundwater flow. If the ground is flat, that means the water table will most likely be flat too. Flow can depend on the amount of recharge the water table gets. So for example, groundwater flow that flows north can shift east or west when snow melts or if there is an increased amount of rain. Shallow wells can be contaminated any part of the year. So some ways to predict groundwater flow are based on surface slope or direction of the bedrock. Groundwater will flow from higher areas to lower areas due to gravity. Also, some factors are surface water, such as ponds or streams. Groundwater will tend to flow towards the bodies of water. Tile drains affect groundwater flow. Agricultural draining that removes water from fields can allow airspace in the soil. So groundwater will want to move towards the agricultural areas that are drained. So flat agricultural land with wells. This can be concerning because we can't predict where the effluent or agricultural groundwater will flow. Should be distanced. The well should be distance greater from contaminants, so at least like 90 meters. It's also easier to move things like fuel tanks further away, and it's also harder to detect fuel in water. Preventing surface water from ponding around the well cap. So we should locate the well away from low areas or depressions in the landscape, as water can pool there. We want to slope the ground away from the existing well, so build a mound around the cap. Also, we want the wellhead to be located away from overhead power lines, trees, outside, and then we want them to be outside of buildings or sheds, and to extend above the surface for easy maintenance and access. Again, if we have to do any maintenance and it's in a building, we have to deconstruct the building to get into the well for maintenance with large machinery. Wells should be inspected after any repairs, cleaning, or installation. If wells are poorly made and not properly sealed, or there are no not maintaining safe distances, this can contaminate the groundwater. Some considerations: wells near roads can be easily contaminated by road salts. Wells can be contaminated by bacteria and nitrates from livestock manure. Tight-fitting well caps and grass around the well cap can prevent pesticides flowing into groundwater and sediment from running off into the well, contaminating the well. So construction. The annular seal. Well casings in a drilled hole protect well from contamination, but there is a gap between that drilled hole and the casing. So outside this well casing, this space is called the annular space. The annular seal should be sealed with a bentonite slurry, cement, grout, or concrete. This seal prevents surface contaminants entering the groundwater. A well drilled into overburden, so things like clay, sand, or gravel, will not seal itself. We need to add an annular seal to this well. Well screens. So these are needed at the bottom of the well. Again, this holds back sediments and allows water into the casing and will protect your pump from destruction. Screen slot size depends on the sediment and the desired well yield. Well screens prevent pump failure by preventing small sediment damaging the pump. If the bedrock is unstable and not fractured, drill wells in bedrock may not need a screen. Well screens can become rusty and lead to collapse. At that point, it can be replaced, or we can install another screen with smaller holes. So flowing wells, when the well has a lot of pressure, when we drill into it, the water can shoot to the surface because of that pressure. We need to control this by reducing the well yield, because this can interfere with other groundwater users and can damage your property or neighboring properties. If water flow from the well, high pressure, or around the casing is not controlled, the well should be capped. Contractors are responsible for capping flowing wells, and most contractors will not service any flowing wells because they are a huge pain in the ass. Overflow pipes can be used to relieve pressure, but are not acceptable practices. Water can be sucked in and contaminate the groundwater from the surface. So pitless adapter. So in a casing, it's inside the casing, the pitless adapter is, and it connects the water lines below the frost line. It's basically an underwater discharge assembly. Well pits. Pits below the frost line that have a well should be kept dry and prevent contamination. It should be an enclosed space. Natural gases can displace oxygen in well pits, so it's important to keep that in mind when servicing them. And well pits are outdated and not commonly used anymore. That being said, it's better to use a pitless adapter. Again, that's a water line below the frost line from the well, and it provides underwater discharge assembly. So old wells, common to drilled new wells. Usually old wells will become a well pit, and the wellhead's extended. The risk of contamination is higher. Anyways, moving on to plugging wells. An unused well can threaten the groundwater, and the owner must seal it. Should be done by a professional, and the pumps must be removed. Also, prior to doing it, to plugging the well must be disinfected. The well screens must be fixed, and the Ministry of Environment will record any sealing. Also, we must ensure that the casing is deep enough so that any future activity won't disturb the plugging of the well.